Hi guys, welcome back. Sorry, extra junk on my screen. Math, section 9.8. We're almost done with chapter 9, which means we're almost at chapter 10. Almost done. Whew. Successive differences. Let's talk about it. I want you to be able to identify a function as either linear, quadratic, or exponential. And we're going to do that based on its graph and its table, parentheses, successive differences, period, close parentheses. It's late. It's late in the day. It's late in the year. I got a typo on the first slide. What are you going to do? Re-record it? Here's the first thing you're going to have to do. The first thing we need to review anyway. I need to figure out a good spot for my head. I think this will work. Let's try it out. The first thing we need to remember is that quadratic functions are shaped like this. And hopefully you remember that this shape is called a parabola. Okay? All right. So if you see a parabola, you know it's a quadratic function. All right. And yes, if you see a shape like this, right, a straight line, which in math we just call a line, then we know that it's linear, okay? Quadratic makes a parabola, linear makes a line, and then don't forget this guy, the kind of roller coaster shape where it gets real flat, approaches a number, never really quite touches it, and then shoots up super duper fast. That's exponential, okay? These are the three types of graphs, three types of functions we're going to be dealing with, and we need to remember their shapes. This is quadratic, this is linear, this is exponential. All stuff we've been looking at throughout the year. We're just going to kind of throw it all together, see if we can differentiate between the three. Cool, let's keep it moving. Here's what the first four problems of the homework are going to look like. It's going to say graph each set of ordered pair and determine if it's linear, quadratic, or an exponential function. I'm going to plot these points, and I'm going to see if they look like a quadratic, a linear equation, or an exponential function. Let's try one out. I've got 2, 3, 1, 1, 0, -1, -1, -3, -2, and -5. And what I'm going to do is I'm going to go over to Desmos, and I'm going to type them in right here. And what's nice about Desmos is as you type them in, it just plots them automatically. Excuse me, baby monitor. Work never stops. Yeah, I'm going to plug them into Desmos. Now, I could make this as a table if I wanted to click on this plus button up here and then just select a table. I could type them in as all the X's and all the Y's, but the homework's going to give them to you like this, so I would just type them in like this. And actually, now that I say that out loud, a lot of you might have the worksheet actually printed out. I know some of you print these out at home, and then of course, if you're with me, you're not watching the video, but still, you can also do this by hand relatively easily. The thing is, once it's done, you just look at the dots and kind of imagine yourself connecting them. And in this case, you can connect them with a straight line, which means that this is linear. Okay. That's it. That's it. Whether you're doing it by hand or in Desmos, if you're going above and beyond and you've got yourself an 84 or TI-84 that you're using, it's still all you're doing, right? You're plotting the points. You're seeing what shape they'd make if you connect the dots. Yeah, it might be in the U shape. It might be in the roller coaster shape. Then you would just change your answer based on that. That's it, though. Okay. I don't want to make this any harder. Let's move on. Successive differences. This is kind of the meat of the chapter. And it's kind of like back when we talked about common difference in chapter 7, but we're going to do it twice in some cases. So here's what the problems are going to look like. They're going to give you a chart, and eventually they're going to ask for an equation. But the first thing we need to do is we need to identify what type of function this table is showing us. So we've got our x values, -2, -1, 0, 1, and 2, and then the y values, -8, -3, 2, 7, and 12. And for successive differences, right, differences is the key word there, we want to figure out what is the common difference between each of these y values. In other words, what am I adding or subtracting between each of these y values to get from one to the next? So like from -8 to -3, how would I get there? I'd add 5. And from -3 to 2, how would I get there? Add 5 again, and add 5 again to get to 7, and add 5 again to get to 12. Okay, so in other words, we've found a common difference, right? And this is this is what we are going to call our first differences, right? In the terms of successive differences, if we see that the first differences, the differences between each of the y values are all the same, then we know that this whole function from the get-go is linear. And it's important that we remember that linear is going to be in the form of y equals mx plus b, our old slope-intercept form. I would take a moment and make sure you write that down in your notes because we are going to be referencing that later when we move over to Desmos to actually write these equations out. So what did we just do? We looked at the table. We figured out the y values were changing by the same number over and over again. So the first differences are the same. And if the first differences are the same, we know it's linear. Y equals mx plus b. We have actually done this before. We're just giving it a new name because of what we're going to do next. Okay? Make sure you got this down. These are first differences. Now, if there's a first difference, what's next? Well, let's check it out. Another very similar problem. X values up top. Really don't need to worry about the x values at all. But the y values, -3, -7, -9 again, -7 again. Okay? Some of you who are especially sharp might be going, that seems like symmetry. We'll get there. If I look for my first differences, right, I figure out what's that common difference between each of these, I'm going to realize pretty quickly it's not common. -3 minus 4 is -7. -7 minus 2 is -9. -9 minus 0 is -9. And then -9 plus 2 is -7. So here's all of our first differences, right? -3 minus 4, minus 2, minus 0, plus 2. These are our first differences, and the first differences are not the same. So this one's not linear, right? Previous example, first differences were the same, so it's linear. This example, they're not the same, so it's not linear. But that's just first differences, and successive means one after the other. So if the first differences aren't the same, let's check the second differences. Well, what's second differences? Well, let's check them out. Second difference is the change in each of these numbers. So how do I get from -4 to -2? Well, I would add 2. How would I get from -2 to -0? I would add 2. How would I get from 0 to positive? You add 2 each time, okay? So the first differences didn't work, but the second differences, that's what these are, they are all the same. And if the second difference is the same, then I know that this function here is quadratic, which you'll remember is of the form y equals ax squared plus bx plus c. Okay, this is our standard form of a quadratic. We've been working with it all chapter 8, all of chapter 9, large chunks of chapter 8. Now we get to kind of see this as a table. Okay, so if first differences are the same, it's linear. If second differences are the same, it is quadratic. Okay, and this is important to know. Make sure you've got this equation written down for reference. We're going to be using it again when it's Desmos. All right, now we talked about quadratic. We talked about linear. We also mentioned exponential. Is there a third difference for exponential? No. For exponential, we've got the common ratio. If we remember from chapter 7, like I said, we've done this before. And in chapter 7, we looked at a table and we said, hey, if I look at these y values, right, 8, 4, 2, 1, 0.5, I said if they had a common ratio, in other words, if I kept dividing and getting the same answer, then they were exponential. So if I do that division, right, if I do 4 divided by 8, that's 1/2. 2 divided by 4, that's 1/2. 1 divided by 2, that's literally 1/2. And then 0.5 divided by 1, guess what? That's also 1/2. So if I take all of these and kind of do that work backwards thing we talked about way back in chapter 7 last trimester, I'll see that these all have a common ratio. And I'll also notice pretty quick, if I check the first differences, it's not going to work. The second differences, it's not going to work because this isn't linear. It's not quadratic. It is exponential. If those ratios are all the same, then I know the graph is going to be exponential. Okay, and give me 1 sec here. I realize I missed something. I'm back, and here's the equation I forgot. It's just like we're in class. I forget stuff. Y equals AB to the x power. That's our equation for any sort of exponential growth, right? Anytime we're doing any kind of exponential equation, once we've found there's a common ratio, I know I'm using y equals a times b to the x. That's the equation that we're going to use once we've verified, okay, this is exponential, the equation is going to be in this format, which is going to be important for when we move over to Desmos here next. Okay, now switching over to Desmos, slowly but surely, there we are. Where's my head going to go? Oh boy, we can do it. There we go. All right, so in Desmos, right, we're going to do a couple different things, and a lot of this will be saved and set up for you, but I want to kind of walk you through how I'm creating this so you can kind of see what's happening. All right, we're going to come back to this problem, and it's a little small here, but we can still kind of make it out. We'll make it bigger over here with Desmos. What we're going to do is we're going to type in the data from this chart, right, from this table. So my x values, -2, tab, -8, there's my first pair, -1, -3, 0, 2, 1, 7, and 2, 12. Okay, there are the 5 points that the problem gave me from the table, right? And then we've already determined it's linear by looking at the first differences. Now we're looking at the points that are getting plotted, and that's also showing us, oh, look, so this is going to be linear based on the shape. So now what I'm going to do is I'm going to type in what's called a regression. We've actually used these before as well. I just haven't made you watch how they get created, but we're getting a little more advanced. It's time to actually learn how to use Desmos. So what we're going to do is we're going to type in y, and then instead of writing equals, we're going to use the tilde sign. The tilde, if you look at your keyboard, is up and to the left next to the number 1. And then I'm going to type in mx plus b. And I've actually got to change 2 little things here. I have to make this y sub 1 and x sub 1, because you'll notice it was x sub 1 and y sub 1 up here when we made the table. And as soon as I do that, look what Desmos does. It draws a line through our 5 points. How neat. And even more important, what does Desmos do? It tells us what m is and what b is. It tells us m is 5 and b is 2. So if the question is asking us, what is the equation for the line or the function that goes through these points, whether it's a linear line, a quadratic parabola, or an exponential loopy-doop, doesn't have a name, I can now write that equation. I could type in y equals 5x plus 2, or just write it down on your paper, and you'll notice it turned blue because now this is blue. That's the equation. All right, so it gives us these parameters that tells us what m and b are in this function. Okay, so that's for linear, and I'm going to leave that up there for now, just so you can see what happens if it's not linear, because this is where your math knowledge is going to come into play here pretty well. I'm going to clear out this table, which is going to be not as easy as I'd like, but I have to backspace it all, and not that one. Yeah, there we go. Okay, I'm back here. And now let's do the one that we said was quadratic, right? We found out the second differences for this one were the same. So now let's type it in, what we get here. Again, it's -3, -3, there's our first point, -2, oops, oh, you poop. Hold on, -3, I didn't realize I was going the wrong direction here. There we go. -2, -7, and -1, -9, and 0, -9, and 1, -7. There we go. Got to press the right button there, Mr. Young. Now, you'll notice it still did a linear regression for our data, right? It still showed that red line trying to go through it. But now, instead of it lining up perfectly with that R value of 1, now the R value is like 0.6, or in this case, -0.6. You guys might remember that's a real weak correlation if you remember way back early trimester 2, maybe even late trimester 1. I don't remember. It's been a while. Anyway, that's no good. But we know it's no good because we've already done the math to figure out, oh yeah, this is quadratic. This is trying to give us a linear equation. To make it give us a quadratic equation, I'm going to do the y1, make sure we do that right again, y1 tilde, right, up and left of 1. And then instead of doing mx plus b, we're going to use the ax squared plus bx plus c we talked about, right? Ax squared plus bx plus c. And then, oh, I forgot the ones. I'm like, oh no, but I messed it up. Type the 1 there. And to get those subscripts, you just type 1 after the x, and it assumes you mean subscripts. And there we go. Okay. And look, now we have a nice green curve that's going right through all of our points. In fact, I'm going to turn the red one off so we don't have to look at it, and we can see boom, 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 boom. It's going through all those points. It's also showing us the vertex and the y-intercept and the x-intercept like it always does. Most importantly, it's going through those 5 points, right? Look at our r value. It's r squared because it's quadratics. But anyway, it's perfect, right? It's a 1. And lo and behold, here's our parameters, right? It's y equals a x squared plus bx plus c. A is 1, b is 1, and c is -9. So it's given us the equation, and it's all right there. Great. Fantastic. One more real fast. We got to talk about exponential. And it's going to work the same. A lot of you are probably thinking like, okay, I got this. I'm ready to move on. But just in case, let's make sure we're on the same boat here. Let's type in our data for the exponential growth curve. So we had -1, 8, 0, 4, 1, 2, 2, 1, and 3.5. And I'm using the tab button to click through those all pretty quick. Now, you'll notice, interestingly, quadratic is pretty close to going through all those points. But if we look at that R value, it's not perfect, right? Remember, we talked about R values being 1, and you want the R value to be 1 on all of these problems. If it's not, you've picked the wrong regression. Okay, so we're not going to use the linear one. We're not going to use the quadratic one, even though it's 0.99, right? It's very close, but it's not quite there. So to get it perfect, because we know it's exponential, to get it perfect, we're going to type in y1 tilde, and then it's ab to the, oops, that's zb. I can type, hold on, here we go. ab to the, and to do the to the, I do the shift 6, in case you guys haven't caught that one. And then I'm going to go to the x sub 1. And remember, if you just type 1 after it, it'll make that little subscript. And then sure enough, you see we've got now a nice kind of purple line. I'm going to turn the green one off so we can see it better. And you'll see that one really zips right through them. My R value, R squared, is 1. And sure enough, there are my parameters, right? A is 4, B is 1. So my equation would be y equals 4 times, 0.5 to the x. And that just perfectly turned black because I changed color of it, okay? All right, so that's your homework. All right, now I'm going to leave this up and I will save this for you guys and share it out. So you don't necessarily have to type these all in, but I did want you to see how these are created, because if we're using, like, so I've talked about using the 84s a lot. We will eventually go back and look at those some more, but we're not using them. And Desmos makes some of this a little too easy sometimes. It's not that much harder on the graphing calculators, but I felt like we could use the examples. So now you'll see how it's created. I'll have it all ready for you like we've done in previous examples. And you don't need to copy and paste anything for this homework. You're just writing down the equation. So make sure you pick the correct regression. You now know which one means which. And then type in your data into the table up at the top. Write down the parameters or plug them into your equation. And that's going to be your what you write down for your homework. All right. A lot of stuff covered in here, but if you have any questions, reach out to me. I'll be available all day. You know I love you guys. Thanks as always for watching. Peace.